once again, when you're not in the form of 1 times x plus a or minus a or whatever way you want to deal with that, set the factor equal to 0. Whatever I'm dividing by, set the 2x plus 3 equal to 0. Solve. And substitute in the negative 3 2's. So as we go through here, what do we have, Mickey, when I multiply by negative 1.5? Negative 15, adding down.
Negative 4, 6, 2, 3, 10.
Should that be a negative 3? Probably.
It should be
Negative 2.
And then the 3
Oh, this should be a negative 2. That would be a positive 3. There we go. Is that better? Let me add down and get a value of 10. Now remember what this value here is. This is our remainder. This is our remainder. We're dividing by an x into our x cubed. So we're going to drop our degree by 1. So we have a 10x squared minus 4x minus 2 plus my remainder 10 over the 2x plus 3. If we look at the problem right before that, divide by long division. We have x squared plus 5. We're dividing this into 3x cubed minus 7x squared plus 15x plus 29. Okay, we have an x squared out there now. When we have an x squared out there, synthetic division goes off the table. The only time we can use synthetic division is if we're in the form x plus a or x minus a. But we still go through the same method of madness. How many times does x squared go into 3x cubed? Jordan, how many times does x squared go into 3x cubed? 3x times. So when I multiply, I get my 3x squared, but this is where you have to watch out. I got 3x times 15 or times 5. That gives me a 15x, which comes over there. I need to take this and multiply it to both of our terms. It's not an x squared term. Okay, I have 3x times 5 gives me 15x. So the degree of the polynomial, the degree of the term, sort of gives us like a place value there. Next thing we do, we need to subtract. So we're going to subtract both of these terms. Make sure you get both of the terms. So 87 minus 84 does not equal 11. The nice thing about it is the 15x cancels out. These cancel out. Both of these give us zeros. I still have a negative 7x squared here. I still have a plus 29 over here. Then we can ask ourselves, so how many times does x squared go into the negative 7x squared? No. Negative 7 times. So we have minus 7 here. We can multiply negative 7x squared minus 35. Remember to subtract because this is a common mistake. You think, all right, I'm done. I don't do this over here. I get a negative 6, which is incorrect. We change both of our signs. This gives me 0. This gives me a 64. So we have 3x minus 7 plus a 64 over x squared plus 5. It's a common mistake, and you'll see sometimes I'll make that same mistake. Other questions you have? Rational root theorem, synthetic substitution. Yeah.
One on the front, I don't care which one. Three.
Okay, problem 3. Number of solutions. Riley, how many solutions we're going to have there? 4. Okay, degree of our polynomial is 4. How many positive solutions? Well, let's check how many signs we change there. How many signs do we change? 2. We go from positive to negative to positive to positive to positive. So we have 2 sign changes. So we have 2 or 0 positive solutions. Now we can put in negative x for x, or we can sort of, skirt the issues here a little bit and maximize our numbers. We have 2 possible positive solutions, or 0. So how many maximum negative solutions does that give us then, Isaac? 2. Because if I'm saying the maximum number of 2 for a positive, that means I have a maximum number of 2 or 0 here. Yeah.
Why do you include the word 0 in the?
Did you look at our notes?
Yeah, that's what I didn't understand.
Okay, how we deal with this is you look at how many sign changes, then -2, -4, -6. You just keep on subtracting 2 off of that. So I start out with 2, I subtract 2, that gives me 0. If I subtract 2, it gives me a negative number of solutions. Doesn't make sense. So we just continue to just subtract off 2, and the same thing here. If this was a value of 3, if we came down to 3 sign changes, we have 3 or 1 solutions, because I subtract 2, because I have 3 sign changes here. So I have 3 sign changes, and then I subtract 2 from that to give me 1. If we take a look at our factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24 are factors of our constant, and 1 and 3 are factors of our leading coefficient. So the list of possible solutions by the rational root theorem. Our possible solutions, we have plus minus all these values divided by 1, which is just going to be all those values. Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24. Those are solutions that could work. Then we take every one of those solutions that could work and divide by my other factor, my leading coefficient, which is 3. So we have plus minus 1/3, plus minus 2/3, plus minus 3/3, but 3/3 gives us 1, so I'm not going to rewrite it. Plus minus 4/3, plus minus 6/3, well 6 divided by 3 is 2, so I'm not going to rewrite it, it's already there. Plus minus 8/3. Plus minus 12/3, well 12/3 is 4, I already have it there, and 24/3 is 8. So these are all my possible solutions that I have. What we're looking to see is which one of these values here make it equal to 0. So we can use our synthetic substitution to see what makes it equal to 0. Now typically what I talked about before, I don't start with the 1s. I start with the 2s and go from there. If you want to start with 1, that's fine. I like to start with 2 because I can eliminate possible factors over here then. So we have 2. I'm going to substitute 2 in there. 2, 3, negative 16, 3, 46, and 24. So subbing it in, yeah, just run it through. 3, 6, negative 10, negative 20, negative 17, negative 34, 12, 24, 48. So the value of our polynomial at the value of 2 is 48. It's not equal to 0. So this does not work. Because we have 48 here for 2, does not work. So if 2 doesn't work, I try negative 2. And run negative 2 through. 3, negative 16, 3, 46, and 24. So running negative 2 through, we have, let's see, 3, negative 6, negative 22, negative 66, negative 63. We're getting really big, aren't we? Once we start getting to a point where I start seeing I'm running really big with this, I'm not going to worry about it. Because this next one's going to be 128 or 126. And it's not going to give me 0 here. That's what I want. This is not going to equal the value 0. So 2 and negative 2, they don't work. They're gone. So I'm going to go to my 3 next. 3, 30, negative 16, 3, 46, 24. And run 3 through. Drop our 3 down, 9, negative 7, negative 21, negative 18. And you can start to see the ones that start having promise here. This gives me negative 54, negative 8, negative 24, and 0. Winner, winner, chicken dinner. So we have our root. X equals 3, and our factor is going to be x minus 3. What we were able to do at this point is we now look at our constant. Our constant is a value of negative 8. Our constant is negative 8, which if I go back to my list of factors here, I can start crossing out values because my factors and my constant have to still work here. Well, my constant's now 8. 3 is not a factor of 8. So 3 is gone. Plus minus 3. 6 is not a factor of 8. So 6's are gone. 12 and 24's are gone. So what we're left with is 1, 4, 8, 1/3, 2/3, 4/3, and 8/3. I'm not going to eliminate these over here yet because I can still have 4 divided by 3. I can still do 2 divided by 3. But I'm not going to worry about my fractions. I'm going to let them come out in the end. I would go 4 next. It's your choice whether you want to go positive or negative. I see I have 2 or 0. I got a positive 3 here. Maybe do a negative here. And run negative 4 through it. -3, negative 12, negative 19. That's going to give me really big, isn't it? So 4 doesn't work, does it? Negative 4 doesn't, does it? Which one works, 4 or negative 4? 4 does. So my number's gonna get really big, so let's take 4 and run 4 through it. 3, negative 7, negative 18, negative 8, 3, 12, 5, 20, 2, 8, 0. So we have x equals 4 is a root, x minus 4 is a factor. And at this point, I would factor this down. I wouldn't go through any more synthetic substitution. We have 3x squared plus 5x plus 2. And factor it down. I think we'll factor the 3x and x plus 2 plus 1. So x would equal negative 2/3, x would equal negative 1. We have 3x plus 2 and x plus 1. If we take a look, what we predicted 2 or 0 positive solutions, well, we have 2 positive solutions, 2 or 0 negative solutions. There's my negative solutions, and these solutions should be somewhere on our list over here. No really easy way of getting through it. Just have to plug and keep on pushing through. Other questions? All right, we have an in-class assignment today. Use your books, notes, homework, just can't use each other. When you're done, there's a worksheet up here for you.